Hi, my name is Darlisha D'Ambert, and for exam 3, the video discussion, I will be talking about positive and negative selection within the thymus. Um, also, I do not mind if you use this video, but to go on, I'll start with positive and negative selection. Like I said, it occurs in the thymus, and I'll start off with positive selection. Positive selection will occur in the cortex. Excuse me. It will have a double positive thymocyte. So with this being, it means the interaction with self and MHC on thymal and epithelial cells. If they do not interact with each other, they will be killed off. With positive interaction with MHCs, it can be either CD8 or CD4, depending on the MHC. So, with that being, for example, if the CD8 is not reacting, that's when the CD4 will come in. So they kind of work hand in hand throughout this process. Going on to negative selection. Negative selection will occur in the medulla. It has air positive cells, so they will express with a lot of MHC and or with self cells. But if it doesn't interact with each other, it would make itself react against its own self, if that makes sense. So, through positive and negative selection, we do have things that are called model systems. And what these model systems do, they help us study these selection processes as far as like negative selection. So we have one, and the first one that I'll talk about is the instructive model. The instructive model, well, I'll be kind of brief, but the instructive model consists of a CD8 engagement signal and a CD4 engagement signal. So they help us identify when those two are coming into play, or help us see and signify when those CD8s or CD4s will ignite. The next one is the stochastic model, and these consist of a random CD4, but they're binding to AG and class 1 MHC. So these are CD4 -8 positive T cells. But again, if they do not bond, they will go into apoptosis. So you'll see an occurrence of cell death if these things are not bonding with each other. The next one I will talk about. Going on. A random CD8. What I'm about to talk about consists of random CD8s. And this is a binding of AG in class 2 MHC, and this will result into a CD4 positive, 8 and negative T cell. So If there is no bonding going on, if they do not bond with each other to AG and class 2 MHC, this is where we will still see apoptosis occurring. Going on to kinetic signaling, the kinetic signaling model, this shows us a strength of signal. So when we see a CD4 positive, 8 positive, we see an engagement signal of the CD8. And so then it becomes a CD4 positive 8. So all that being said, still under kinetic signaling model, we'll see a disruption of the TCR signal, leaving us with a CD4 8 positive T cell, and also a continuous TCR signal, which also leaves us with a CD4 positive 8 T cell as well. So just kind of going over all of that, referring to my notes real quick. Just an overview of what I just kind of went over. We know that positive and negative selection, that process typically occurs within the thymus. Well, it does occur. It doesn't typically occur, but it does. Positive selection emerges out of the cortex. It's a double positive thymocyte that resides there. We'll then see interactions with self-antigen in the cortex with self cells, and MHCs, resulting into either a CD4 or a CD8, which it depends on the MHC, what MHC is being produced. We know in the medulla there is positive selection that occurs there, and also we have air positive cells that express large, significant amounts of MHC when they react with each other. And then the last thing we had talked about were those model systems. And those model systems, they help us study negative selection. And those systems are instructive, stochastic, and kinetic. And that is all for today.